This is my code demonstration for part 2 of PROG 7312. This is the local events and announcements feature. So firstly, I will be discussing the data structures, the underlying data structures I used, and then how I built on it in the application. So firstly, also I have provided links to the information I used online to help create the data structures. This will all be on my code in GitHub. So firstly, I created a class, a queue class. So I had to name it differently because the queue keyword is reserved for the IDE, so it'll cause errors if I used queue. Um, so I created a public class. Over here, the T just allows the data to be generic, so it's not of a certain type. So it doesn't have to be specifically string or an integer. The I enumerable, it just allows me to use my for each loops later on. It just allows me to iterate through my items. Over here, I create a list of type T, so it's generic, it doesn't have a specific type, and it stores items. So this allows me to store the items in local storage, which allows me to get the queues, or allows me to perform the features of a queue. So over here, I create a constructor where I initialize items to a new object list. Over here, I use count, which helps me get the number of elements within a list. And then because I use the first in, first out principle, so because queues use first in, first out principles, um, I when you add an element, it adds it to the last index of the list or the queue. So if I had something at index 0 and then nothing at index 1, so it's just one element, then it will add it to index 1. And then DQ, because it works again with first in, first out principles, it removes the first element within the list. So over here, I check if the queue is empty first because you don't want to remove from the queue if there's no elements. It will cause compilation errors. Then over here, I just get the item and remove it. Peek just allows me to get a specific item or get the first item without dequeuing, so without removing the element. And then over here, I have a print, which I mainly use for debugging purposes to make sure my queue is working well. And then I use IEnumerators or IEnumerables, IEnumerators, sorry, over here so that I could loop through the elements. So the get enumerator, I use it, well, it's required for me to use it because IEnumerable inherits from non-generics, so that's why I had to use it. Um, then for my linked list, again, I created my own class. It's also generic. And then I defined head and tail nodes. So because I'm using a singly linked list, the head, so one linked node instantly represents the next node. So that's why it's just heads and tail, or it's a head and tail node. And then I have count to get the number of nodes in a list. Over here, I define a constructor, which is basically a single linked list or single node or element within the linked list. Um, then over here, this adds an element to the last position or at the end of the list. So it checks if the list is empty, and then the head and tail will point to the new node. Otherwise, the tail will point to the new node, and then the tail will be updated. And then I increment the number of elements basically. And then over here is a remove. So over here, I remove a specific node object from the list. So here I check if the head, so I check if the node is the head, and then it obviously adjusts compared to that. And then I iterate through the list to find the node before I iterate through the nodes before the one to remove. And then I update the tail if the remove node was the last one. And then I decrement count. And then I have another remove. So this one is if it matches a certain value. And then I use the equality comparer to perform generic comparisons. So I used it for that part. And then it returns true if a node was removed or false if it was not. And it handles different cases. So for the contains, it checks if a specific value exists and it'll iterate through each header node until it's found. And then it would return true if it was, and then return false if it wasn't. And then again, IEnumerable is primarily for allowing me to loop through the elements. And then over here, I return, which allows me to get an item one at a time without creating a separate collection. Then there's my hash set that I used. So the hash set was used in for the dates and um, the categories, so ensuring that each one was unique, so it wasn't redisplaying multiple. So again, my code that I referenced. So I created a class again and it's generic. So over here, I get I created initial capacity. So it's the starting capacity for my hash set. So this so this part so this allows me to ensure that my hash set is flexible. It can be dynamic at whatever um, amount it is. So if it needs to increase, it can increase. If it needs to if it needs to increase, it can increase if it's becoming too full. Over here is a load factor. So the load factor primarily just allows me to check if it's a certain amount full, the hash set, and then if it reaches that point of 75% full, it will increase it by yeah. And then over here I create a buckets or I use the linked list that I created myself, the data structure I created myself. And this is basically an array of linked list of separate chaining to handle. So this is for collision handling. And then this just is the size, which gets the total number of elements in the hash set. So over here is another constructor. I initialize buckets to the initial capacity of 16, and then I ensure the size is 0. Um, then there's get bucket index. So this computes the bucket index for a value. This part just makes sure that it's a positive hash because you can't have a negative. And then this just makes sure it's within the bounds of the array. Then over here is my adding. So I check if resizing is needed firstly, if it's not if it's not full yet, or reaches the load factor threshold. And then I find a bucket for the value. Then if the bucket is null, I initialize it to a new linked list, the one I created by myself. And then I add the value if it's not already present. So this ensures that each element is unique, and then it increments the size. And then over here, it just checks the contains, just checks if a specific value exists in the hash set, and then just to look for the appropriate bucket for it. This is my remove um, method. So it removes an element from the hash set and returns true if it was found, and returns false if it wasn't. And then it decrements the size of the array. This is my resize method. So it doubles the size of the bucket when the load factor reaches the minimum amount of 75% over here. And then it just is basically just recalculating the bucket index for each existing item, and then ensures all the items are transferred to new buckets. And then I use enumerators as well to loop through items, to allow me to loop through new items. Then I used dictionary. This is to store and organize the events and the announcements. So again, I created my own dictionary, created key value pairs of key and value. It's also of type T, so it's generic. I also define initial capacity, buckets again for collision handling, and then the count. And then again, a constructor with initializing buckets to the initial capacity, and then defining my count as 0, so the number of elements. Um, so the get bucket index um, basically creates which buckets a key belongs to, and uses the absolute built-in math function to avoid negative uh, indexes. Over here is my add method. So I add a new key value pair. It throws if my key is null already exists. And then it will um, so it throws if the key is already exists, or the index already exists. Um, and then it'll add to the end of the buckets linked list, and then it'll just resize if um, if it reaches that threshold again. And then over here I have a get, which retrieves the value for a key and throws an exception if the key doesn't exist. Um, Over here I check if it contains the key. So again, I check for the key, and if the key doesn't exist, oh well, in this case it will just return true or false if the key is found or not. Over here is a remove. So if I want to delete elements from my dictionary, so it removes a key value pair if it exists, and then return true if it was successfully removed, or return false if it wasn't. Um, then for this t value part over here, it's basically I get the value, or I retrieve a value, and then over here set So it updates the existing key or adds a new one. Uh, and then again, these elements just allow me to iterate through elements in the dictionary with my for each loops. And then over here is the code I use to resize and rehash. So it doubles the size if it reaches that threshold, and it'll rehash all key value pairs into new buckets, and then it will reset the count. Um, and then it'll add increments. And so that are the data structures I used. So in terms of my models, um, I created two models, announcements and events. So events, I create a unique ID. I dis I allow for title, description, location, category, start date, and end date to be stored. And then similarly for announcements, it stores the announcement ID. It gets titles, categories, messages, and the date. So those were the models I created. And then in I created two data components. So one handles announcements and one local handles local events. So over here I get the new so I get the data structures I created so that I can store or retrieve as needed in the application. So over here I create a constructor which helps me which I have where I seed the roles. So this is my method where I seed the roles. So over here is the different values I've added. And then add event is another method. So for add event, this first part just makes sure that no duplicates can be made. So no duplicate IDs exist. And then it adds an event to the event dictionary and it adds the category and so it adds the category to the hash set and it adds the um and then it adds the event to the queue. So I have a max recent over here. So this ensures that basically mm, the events are current or what's current. So it'll just dequeue the previous event if it reaches 5. Over here, I get filtered events. So over here, I return a list of events filtered by category and so either category or the date. So those are the two unique elements that they can be sorted by or sorted together with. So over here, I use a link query where I retrieve the category where the category equals to that specific element or elements. And then similarly for the date, I use a link query where I get I filter it by the start date. So anything within that time period or that start date will be displayed to the user. And then it's ordered by the start date. So the most recent, so the earliest event will be displayed first. Over here, I return a sorted list of unique elements. Over here, I return the unique dates. So over here, I return categories, and over here, I return the unique dates. And then over here was debugging and testing, which was for my own use. Uh, And then here's the other one for announcements. So it does similar processes. I use the dictionaries, a hash set, and a queue. And then I also make sure that the announcements are relevant. So I max it out to 5. Over here is the values I seed, which is over here. And then add announcements. I check if the announcements ID already exists. And then if it doesn't exist, I add it. I add announcements to the dictionary. And then over here, I add category, and I will add the announcement to the queue, and then BQ anything that is above the recent elements. Um, Over here, I have get announcements. So over here, it returns announcements by optionally filtered categories. So over here is another link query. And then over here, it returns the elements by date. And then over here, it just gets unique categories, elements. And then over here is another debug processes I use for my own testing purposes. And then I have a controller. So the controller does the heart of the code. It joins both the data folders together so that it all works together on the front page for the user. So I get my both the local events and announcements classes. And then over here is the index page, which the user sees and where it displays onto the page. So over here, I created variables where it's basically done on a specific, so the user can get elements or filter based on the search bar, the category, the date, or based on announcements categories. So over here, yeah, so it basically just gets my elements. So it allows them to search by text, search by category, by date, or by, well, there's two different categories. So there's a category for the local events and there's a category for the announcements. So over here, I pass the date, the filter, the category filter, the date filter into a date time variable. So over here, I pass it. And then I use nullable over here because it's optional. The user can choose to filter if they want. And then over here, I use the class I created for the manager to filter events by category and by date. And then over here is the search where they can search by a specific keyword, either in the title or the description. And then it just ignores any case sensitivity. And then similarly over here, it just retrieves that filtered data. Then over here, I have a local events. So it gets the model, which basically contains the filtered events and announcements, the search keywords, um, the selected filters, and the categories and unique dates. And then over here, I just call in my testing from here. So these are just the things I use to test if my code was actually working. Oh, and in my models, I have this view model. So this part over here just gets the filtered events. This gets the what the user's keywords were searched in the search bar. This gets the categories. This gets all the categories that are displayed in the hash set. And this gets the selected category the user has. Again, this gets all the dates. And then this gets the selected date the user has. And then over here, announcements, it gets all the announcements categories, and then gets all the announcements. And then it over here gets all the announcement categories from the hash set. And then over here, it gets the one the user selected. So if I had to execute my application, this is the home page. Here is the view issues page where the user can still report an issue. That was part one. And then over here is the local events and announcements. So from the data that was seeded, this is announcements, and this is my events. So if I look over here, here is a food fair, and then over here is also a food fair. Over here is trick and treat. So over here is the dates. Here is the category. Here is the title. Here's the location, and then here is the description. So if I were to search food fair and filter, it would just get food fair. And then if I had to refilter, so there's two dance categories. So if I say dance, it'll get these two. And then if I had to search dance, so it's working with the one filter, and then dance festival, it'll just return this element over here. And then if I alternatively choose dance, so they're gonna both, so it's gonna display both, and these are both on the same day. So if I had to show it, um, so if I had to select dates, so these are the two dates that are unique in the set. So if I display on the 18th, it's gonna put these three elements. It's gonna filter to those three elements. And then for announcements, it just allows the use, so it will display all the announcements again using only a max of 5, so it remains current. And then it'll display by event and notice, because notice and event are the only two category filters in this case, which are unique. And then if I press filter, it would just display the event. So if I had to add another element to the announcements, I have to copy this. Um, New water park opening. This will be an event. Um, Join us in Santon for the new water park opening on the 15th of October 2025. So then over here, they will just choose this date. So it'll be the 15th. Then if I save, re-execute, Okay. Okay, so it gets the new park opening, the event, if I filter. Oh, so I need to change. So over here, it just had to be a unique ID, which I did cater for in the code. So it was here. I firstly check if it's over here. I check if it's unique. That's why I never display. So if I save it, I refresh. So over here, the new water park is opening. If I open the page, here, the new water park opening. And it comes first because it's ordered by date. And then if I had to filter by event, it will display just the two elements. So in terms of the hash set being used, it was over here to ensure that each element is unique. Over here it's by date, so each date is unique, and over here make sure that each category is unique. So if I were to add a new element in this page, so I just changed the ID to 6, uh, early Christmas. Um, I'll just change the category for this purpose to Christmas. Um, take your kids to the new Christmas fair, and then the dates. So for unique sakes, I'll this 11 and 11, and then the location, Santon. And then if I save it, reload the page, here it displays early Christmas. So if I go to dates, I can filter it to the 15th of November now. And then categories, I also have the category of Christmas. So if I filter, it'll display that. Thank you very much for listening to my code demonstration.